In this video, I'd like to show you how to write an equation that can match up with a line that you see on a graph. So this graph shows a little story about someone or something traveling some number of miles from home as the hours go by. And so if I'm going to write an equation, I want to figure out a couple of things. First, I have to figure out where is this person starting. The starting distance is 40, and what's the speed of this person as they travel. So those are the couple of things that I'm going to need to figure out. So in general, I know that the equation that I'm going to be writing here is going to look like this. So the distance from home after any number of hours, well, it's going to start at 40 and it's going to be decreasing from there. So the current distance, the equation is going to look something like this. The current distance is equal to 40 minus however far we've traveled after that certain number of hours. So it's going to be a subtraction problem. So the starting point minus how far you've gone. And to figure out how far you've gone, the miles traveled is going to be the miles per hour times the number of hours, or a rate times the time. So I've got miles and hours. So I need to calculate the miles per hour. So the overall equation then is going to look like this. That subtracting that miles traveled, that is a rate times the time. So the current distance is going to be equal to 40 minus 40 miles that we start with minus the rate times the time. So for all of these equations, these linear equations where there's this constant rate of change, they all have the same form, and it's going to be written in the form of y is equal to mx plus b. Or if we rearrange it, I actually prefer the other way. If I put the b first, y is equal to b plus or minus m times x. And I can see now that the y, in this case, for this particular story, the y is on the y-axis is going to be my miles from home. So y is equal to miles. The x in the equation represents the values on the x-axis, which are hours. So x is hours. The b is your starting point of 40. So the b is the beginning point, or the starting point. Or on the graph, this is sometimes referred to as the y-intercept, where this red line hits the y-axis. So the beginning point, or the y-intercept, in this case is 40. And that leaves me with the rate of change is m. That's what I still need to figure out. How many miles per hour is this person traveling? So if I push some of this out of the way, I know my equation is going to look like y is equal to y, the distance in miles, after some number of hours is going to be equal to the starting location of 40 minus how far they've gone. So some number times x. So my job now is to figure out what that rate is. And to figure out the rate of change, I want to pick two different times and figure out the miles and the hours in between them. So for example, I could take the starting distance of 40, and I can see here after 2 hours time, the distance is 30. So it looks like in 2 hours time, 2 hours, the distance has decreased by 10 miles. So if I'm going to do, if the distance decreases by 10 miles in 2 hours, that is going to be equal to negative 5 miles per hour. Negative. Notice that the line is going down. This is a negative slope, a negative rate of change. So this is going to be minus 5 miles per hour. There's another reason I know why that's a negative sign. 40 minus 5 miles per hour times x hours. And so right here, that is our equation. It's always a good idea to test it. So let's try this thing. Let's see if the equation can predict a correct distance based on the graph. Let's pick x hours. Let's x hours of 4. When x is 4, this graph says when x is 4 miles, the graph says y will be 20 miles. Let's see if the equation agrees. So if I take my equation, y is equal to 40 minus 5 times, if I replace x with 4 hours, because the x values are hours, that's going to be 40 minus 5 times 4, or 40 minus 20, and 40 minus 20 is 20 miles. So the equation, I got the equation by getting a starting point and getting a rate of change. My starting point was 40, my rate of change was negative 5 miles per hour, and then I could write this as y, the distance in miles at any time, is equal to 40 miles that I start with minus 5 miles per hour times x hours, and then I even tested it to make sure it works.